Hello, good morning. Salam Sejahtera. It's very pleasure to see so many of you online this morning and making it starting grand opening at 10 o'clock. And for the next 2 hours, and we were actually very deep pleasure to introduce to you Introduction to Wolfram Mathematica. I know some of you might have been a user for a while, but today I think either you have been existing users or you are completely new to this technology. I believe that you are, after the event, you'll find yourself actually further enriched, not just in the knowledge and about knowing what Wolfram Mathematica technology is, but actually help you to arm yourself with extra tools, extra tips, and also extra know-hows, how to make your assignments and project, or even R&D to be a slightly actually more efficient with the available technology for you. So today, it's our pleasure to have our speakers and also trainer and also our coach, senior coach for Wolfram Mathematica, Desmond, will help you for next 2 hours. Meanwhile, if you during the sessions, if you do have any questions at all, you are most welcome to put it either in a Q&A. I suggest you put a Q&A, yeah, so everyone can see it and also we can answer accordingly in a more friendly, streamlined way. I'll be actually the assistant answering any question you might have during the session. I pass the time to Desmond. Thank you very much. Yeah, enjoy.
Hi, good morning, everyone. My name is Desmond Lim. So today I will be the facilitator for you throughout these 2 hours. As the topic suggested is an introduction to Mathematica. So it will be easy, quick started. No worry that you have experience in programming or not, or you have experience with Mathematica or not. This is a section that to get you started with. So without further ado, we have 2 hours, but we have a lot of packed material for you. So let me share the screen to you right now. Okay, those are the slides for today. The material will be available. I will share the link to you later on that you can download it and also work on it, because today will be more like a hands-on workshop so that you actually can do something to familiar yourself with the software. Okay, as the name suggests, introductions, we'll go through some background, right? So what is Mathematica and the Wolfram language? Sometimes we heard people say about Mathematica, sometimes you heard about Wolfram language. Actually, there are some difference. Mathematica is the software that actually a flagship product from Wolfram that 35 years ago is symbolic and numerical computation tools. Whereas the Wolfram language is the programming language that power the Mathematica and some other Wolfram products like Wolfram Alpha, Wolfram Engine, Wolfram Cloud, and so on. Okay, those are the different, but sometimes we say both like Mathematica or Wolfram language actually will mean the same thing. This is the Wolfram technology. Right? This program or this language have been widely used on the world top 200 universities. Okay, and locally there are some campus that actually have this license fully available to all the faculties and students, such as like USM, all three campuses. UM and Monash, they have all those licenses available to the students and the lecturer as long as they have a valid email address. And some other university locally, they also have this license, whether in their lab or as a group license or their research license as well. Okay, you probably can check with your university. Some of the lab probably could contain some of the Wolfram Mathematica license, whether it's current version or the previous versions. And some thing people say about Mathematica is that Mathematica, okay, when the first talk about Mathematica, people say, okay, Mathematica can do some symbolic computations very easily. Like this is how we actually write the coding. Say we want to solve the ax squared plus bs plus c equal to 0. This equation in terms of x, you just type like this, you get the answer right away. Okay, this is the input, this will be the output. And also people say it can solve some math problems, like you want to solve the x double prime t plus 3x prime t and 2xt equal to 0, you can get the answer easily as well. And also Mathematica contain a lot of symbolic output or input that can use. For instance, you can have this mathematical symbol that can recognize and compute right away. If I run this one, you can see the output is a pi. They can straight away give you the symbolic output rather than just numerical values. And also like this one for the limits, you can get the answer like the negative infinitive. You can get the right answer right away with this computation engine. And also people will say that Wolfram Mathematica or Wolfram language can make some interactive visual very easily. For instance, if I want to show the sine omega t plus phi with a range for the t and the range for the omega and phi, just within one line of coding, you can create a interactive visual output like this. So this is the output that we create by changing the value of the omega. You can see the curve can dynamically display right away. Okay, and this is some simple one, but you can also create something more complicated like this one, just to demonstrate maybe your idea, your theorems, or your research work by using the manipulate function in Mathematica within a certain line of work. Okay, this is something people talk about from Mathematica, but there are much more we can do. Okay, if you go to the Wolfram user community, you further scroll down, you can see those are all the topics people actually discussing with the Wolfram language or Mathematica. You can see there's a lot of area that people are using. People talk Mathematica maybe for mathematics only. Well, yes, at the beginning probably is, but until the 35 years later on, it have been grown to all the different domains. You can see different topics are available, different category domain are available in the Wolfram Mathematica itself. like signal processing, graph, visual, earth science, and software development. I believe if you further scroll down here, there will be at least a few of the sections or a few of the category you will be interested with or you will be involved with. So if you are not from mathematics or from computer science, Mathematica or Wolfram language still something work for you to explore with. You can see there will latest will be with the machine learning, neural networks, optimizations. All those topics are actually available in Wolfram Mathematica, and it doesn't like other tools that you need to buy extra toolboxes for certain usage. In Mathematica, everything are included in one software. So you do not worry that whether you have these toolboxes or not. Everything is in this single software itself. Whether you have it right now as a license from the campus or you have a trial license right now, you can access all these categories or all these toolboxes. Right? Okay, let me, before I go into a hands-on, let me show the link for you so that you can download all the hands-on that we can do it together. Let me put in a chat room. Okay, please download the today's material. Okay, let me also put in a screen here. Okay, this is the URL that you can go to open out this material itself in the browser. And in the browser, you open it, just as a viewer, you can see all the detail inside. But since today you want to be hands-on so that you can get more experience and know how to work around with Mathematica, I would suggest you open this one, then you click the button to download the whole file and open in your local Mathematica so that you can go together with me during this training workshop, right? So why don't we try together, go to this website. If you already come to this website, you should be able to see this. Let me show the link after you come to this website. Okay, this is the website link. If you click on the link I put is posted in the chat room, it will bring you to this cloud versions. So you can see it's just the slide that I shared with you a few minutes ago. Okay. As I mentioned, you can see every slide, but you don't really can do computation inside here. So you will look at the button at the top right here. It says make your own copy. If you click to make your own copy, then you actually can work around with it. Okay. Of course, the first time when you come to the cloud, you ask you to log in with your Wolfram ID. For those like from the university that I mentioned just now, 3 university, if you still remember USM, UM, and Monash, okay, you have the desktop license already. But especially for the Monash and UM, they also have extra license with the cloud versions. So if you have the cloud version, you actually can log in with your Wolfram ID here. If you log in with your Wolfram ID, you can straight away working the whole Wolfram technology in the cloud without download to the desktop version. But it's up to you, because when you're running in the cloud, you probably need the internet connections. Okay, but you're not worried about your computer spec, whether it's slow or not. But if you want to work in working on the desktop version, I would suggest you just click download it and open it in your desktop. All right. I hope everyone get ready, so then we'll get started. Let me move it back to my desktop version. Let me remove this one. All right. This what you see on the screen right now is already inside Wolfram Mathematica. Okay, but you can see it's just like a slide show in other software, because in Mathematica it allows us to actually to adjust our screen in different environment. So when you want to easily present it or demonstrate, you can use a slideshow mode. But if you want to do some calculations or programming, probably we will suggest you to change it back to the working mode. So how to change back to the working mode? I'll go to the format here and go to screen environment and select working. Okay, this is because of different mode, you have a different arrangement on the presentations. So working mode will be much more easy if you want to write your code and execute something on compared to the slideshow mode, right? So I suggest you go to the working mode and click inside here. Okay, once I click the format screen environment to the working mode, this is how it looks like. Okay, you can see all the slide in a vertical rolling pattern. Okay, now it's on the slide 6 of 22. If this is something very new to you when the first time log into Mathematica, you will see the welcome screen from the Wolfram language. If you launch your Wolfram Mathematica, there will be a welcome screen. Let me show you the welcome screen. You'll see something like this. Okay. And what you need to do is you click a new environment, new document. Okay, this is something, a new file open up. You say untitled 1. This is the exact Wolfram desktop. You will see when you first open a file. So you can see this is a horizontal gray line at the top with a cursor blinking. So this is, we call it insertion line or input line. Okay, this is where we start input something. So for instance, if I want to do some calculation, I just start 5, maybe multiply by 6. And then what I need to do is to evaluate your input, you need to press Shift plus Enter. So this is my input. I want to evaluate. I use a Shift plus Enter at the same time. You send the input line in the computer for the calculation, and you give me the output, okay, 30. Okay. In a MacBook, you probably use a Shift plus Return button. Okay. And at the right hand side here, you have probably, you will see in and out. In number 16, out number 16. Your one will be different from mine because I opened the sections earlier before this presentation and I have run 15 calculation before. So every section you open it up, seeing the until I close the Mathematica, you actually have a specific number assigned to the input line and output line, so that we can easily go to the input line and output line to search for our previous enters. So my one is 16, your one probably is 1 and out 1. So this is one pair. Let me close this notebook and come back to our slide here. Okay. In this slide, I actually have made some changes or some default to the input line. So all the input line, I put it as with the light blue background color. So when you see the light blue background color, this is considered the input line. In Mathematica, there will be, you will see a lot of bracket at the right hand side here. Okay. Each bracket is actually conclude one, we call a compute cell or one cell. Okay. The cell, it could be multiple line. It doesn't matter. Seeing like this is 2 line or 2 row is also considered one cell. If I right click on it, you'll see that if I move to the style, it will tell me the style of this cell is text. Okay. If I go to the very top, this one, for the simple calculation, I right click, I go to style, it show me this is section title. Okay. So they have very clear categorized for each input or each cell. If I go to this blue color one, I come to the style, it say this is input. By default, is an input cell, means a command input cell. Okay. If I don't choose anything and when I key in as a new cell, it's always a input cell. Right? Oh, I see. Oh, okay. The password is Mathematica. Sorry, I forgot to mention about this one. Sorry about that. I think you are not able to download it and open it just now. Yeah. The password is Mathematica. I probably should wait for you for a while before I further continue so that you can catch up. So you open this file and you click, if you have the cloud version, you can run on the browser, any browser, you make your own copy. Or if you prefer, you can download the whole file to your local PC and then open with your desktop version. All right. We're still going through with some very basic things, so not to worry if you just getting download the whole file. We are not now on the slide 6 of 22. So if you already happen to download the whole file and open this MB with this file in Mathematica is always .mb with the extension .mb. So you open this file and then you can go to format, go to screen environment, change to working mode. And at the very bottom right-hand side, you can see there will a magnifier, how many percentage you want to show your screen so that you can adjust the screen size, the font size to suit your needs, okay? Now, as I mentioned, all the Mathematica actually are created or combined with a lot of different cells in the bracket you can see at the right-hand side here. Okay, each bracket is correspond to one cell, whether it's a text cell, default input cell, or any other cells available. Okay, so I will ask you to follow this through. Whenever you see a light blue cell, you just put your cursor inside that cell, anywhere in the cursor, anywhere in the text, and then just press Shift plus Enter to execute it. Okay. This is how actually we'll go through the whole section today. When you see there is a black blue cell, you just put your cursor there, Shift plus Enter. So you actually compute the 456 multiplied by 2, you get the output 912. This is how you get input, output. And you can see those two cells are actually grouped by a larger cell, larger bracket, okay? Larger bracket outside so that you know they are one pair. Okay, and the bracket here, if you double click on the larger bracket, it actually will hide the output. Okay, if you see, if I double click on the output, double click on the outer bracket, it actually hide the output cell. Okay, after the output cell is hidden, you can see the bracket, the larger bracket, you have a small arrow pointing to the bottom. If you notice this, when at the right hand side here, let me, if you need the annotations. Okay. That's what I mentioned about if you look at the just a second, let me check. Okay. If you look at the right hand side, this bracket, right hand bracket, there will be options for us to hidden the output or to show the output. So that will be easy for you to arrange your notebook for a cleaner space. So you can either hide it by double click or open it by double click. right? So let us move to another one. So to enter another input, what we do is after we get the output, you can use your mouse to move anywhere in between the cell bracket. You can see at the right hand side here, there'll be a cell bracket. If you click between the cell bracket, there will be a horizontal gray line appear. Okay, this is for you to insert your new input cell. That means Mathematica is very flexible. You can create a new input cell anywhere in between existing cell. So when it's in between existing cell, you can click on it, and then you see the cursor is blinking, meaning I can start typing here. So if I click here, there's blinking, I can start typing, say 4 plus 5, shift enter. There will be a new input in between. I can simply insert anywhere I want. And if you don't want this, what we need to do is we select the bracket and then right mouse button, select cut to remove it. If something happened to my file, we probably do the annotation and maybe hang my PC already. Just a second though. Not moving. I'll open it again. So this, when we first launched Mathematica, this is what we see with the welcome screen. And then I can select the recent file straight away by clicking here. So I move back to the new file. And I move to the slide or I can select straight away to the slide I'm looking for. So simple calculations, slide number 6. And then I change my format with the screen environment to working. Okay, we are back here. All right. So let me add. So we already know how to execute the command by using Shift Enter. And to enter a new input, simply click anywhere in between the bracket and for a new input cell. So we run everything inside this file at the light blue black cell. So to execute it, okay, this is how you execute. And also you can use you can input the text in between inside your input cell so that you know what this is for. You can put in your own note by using this symbol bracket plus the star and close with a star plus closing bracket. So you can insert your note here. When you execute it, Mathematica will know you skip anything in between this symbol, but it just run anything outside there. So you run this for factorial without looking inside whatever you type here. So this is how handy we can insert the text note within a calculation cell. Okay, and we can type our own inputs by just do some exercise with your own. So we just key in some input in this. When you see the pink cell means for you to input the new calculations. So we type something like 217 divided by 7 and then shift enter. Okay, you'll see this simply easily calculate. But I want to demonstrate is we can always easily go back to our input line and change the value. Let's say I change to 216 divided by 7 and then shift enter. The output will show exactly the same. Okay, that is because Mathematica always gives us the exact value or symbolic output. Unless your input is numerical, then you show me the numerical input. So if I say 216.0, that is a numerical value divided by 7, then you give me the approximate numerical output. Okay, Mathematica will not automatically change whatever symbolic input to the numerical output unless the user asks it to. Okay, this is the difference between. So sometimes you see why the output looks exactly the same as the input. That's mean it's not doing the calculation yet. Okay, this is how we change it. Or alternatively, you can do something like instead of 216 divided by 7, you can use a function called n and close it with the square bracket. Say I want the numerical value for this output, then you change it for us. Okay, we'll come back more on this Wolfram programming language later on. Another things probably will be handy is using the symbol called percentage. Percentage is to call the last result that you generate in this workbook. Okay, percentage straight away refer to the last one. The last one, my one is output number 8. So if I say percentage number 8, sorry, if I just put percentage, you show me again the last output. So the last output is 30.8571. It came back with this one. So if I say output number 3, so percentage 3, you show me the last output number 3 is value with 24. Okay, we can easily refer to any output value you want. And you also can say, I want the output number 3 minus 5. You can straight away do the calculation. If you have a serial calculation, you can write your next code, next line of code like this, so that you get the output that you want. You can just use it. And this is how it works, like percentage multiplied by 2. The last output is 19. If I say percentage multiplied by 2, then you get the 38. Okay. If this is not if you want to remove anything that in the screen that you don't need anymore, you can just go to select the bracket and then right mouse button using cut to remove it, or you can select it and then press your keyboard delete button. Then you delete any cell that you don't want anymore. Okay. Okay, just now is some basic arithmetic calculations. Okay, but in Wolfram Mathematica, they also have something built in called natural language input. Okay, you can easily key in your query using the English input, just like what we speak normally. Say, let's say I want to solve 7x minus 2. So you just type solve 7x minus 2. The only requirement is you have to start using by typing equal sign. So you can see there will be a symbol rectangle orange color equal showing up at the front. Whenever you have this symbol, it means it's activate the natural language input. Means that you don't need to worry about the programming language, but you just type as the natural language. So if I have this one, I just press enter, and then the whole thing you actually go through. You can see the right hand bracket become black color. It means that it send the whole information to our server to understand what we're looking for and come back with the answer. So it solve this 7x minus 2, it give me the output x is equal to 2 over 7, right? And we can also say, please plot this two equation or two equations. Plot the two equation with the x equal to 1 to 8. Sorry, they plot these three equation with the x from the range 1 to 8. So you show automatically plot this out. Okay, without actually knowing the programming Wolfram language. As you can see, if you notice, every input it interpret and then come back with the actual Wolfram language at the bottom here. Means that if you want to use a Wolfram language to get this output, this is how actually we should write. Okay, this is how actually we should write. But for the beginner, Wolfram language input, it will be very handy. You don't need to know all those programming language. So let us try out with some example. So if I want to do the integration of x squared, sine x to the power of 3 with the derivative. So this is how I probably can start doing. So in the input cell here, you press the equal sign to call out this orange color rectangle thing. And then say integrate, maybe integrate. Maybe I just copy the whole formula inside here. So integrate this one for me, and then press enter. Okay, so you get your output. Straight away you say, okay, you know what to do, this is the output, right? So they will be very handy. And also, okay, well, how about I want to do the to find the area between this one. So I again press the equal sign, say, okay, find area between, again, instead of typing, maybe I just copy the whole thing and then paste it back. Enter. See whether you understand what are we actually looking for. So I want to find the area between these two curves. So you say, okay, understand this and try to, oh, you haven't came out anything. This is the applications. Okay, 27. The answer is 27, the area between these two. And you see there will be a plus sign, orange color at the right end here to show all results. Without clicking this, with this symbol, equal sign, it always came back with a simplified, a single line straight away to the answer. But if you click on the show all result, it show all the relevant thing with your input and some relevant output as well. So if I click on the plus sign, it show me all the details in between. Okay, so these are the two curves. Those are the result to 27 and some relevant plot as well. And you can even click step-by-step solutions to see how you end up the answer of 27. Okay, this is how it show us. If you click the plus sign beside your input here, it is where I click just now. Okay. For next week, Thursday, the next section, we will actually specific on this area using this we call Wolfram knowledge-based engine. We have the whole section talking about this and how to apply all the feature inside here. So the next thing we want to try is using the chemistry equation. There's a lot of things you can check with this Wolfram Mathematica. So I just copy the whole thing, highlight the thing, and then copy and then put it here with the equal sign. Remember, you always need to start with the equal sign for the Wolfram natural language. And enter. It takes a while. It depends on the connection as well. So we'll get the balance equation for us. This is the equation output. If you want to see further details or all the results relevant to this one, you click the show all result. Okay, we just skip that one. So how about we want to find the formula for water flow through a 100 cm diameter pipe. So I see whether you understand if I just copy the whole sentence. Sometimes it might not understand if the whole sentence is too vague or not specific enough, then it would not understand. So we want to check again to make sure that our input is straight to the question we're looking for. Okay, and we also can find the wind speed at our current locations. So what I need to do, equal sign, say wind speed. I don't even need to mention my location because it's just like you're using Google, it always assumes with our IP where we are and find out the result for us. So it's 2 meters per second, which is collected. This data was collected 39 minutes ago. Okay. And also we can list the element with melting point. We can say I want the elements melting point between 200 degrees Celsius to 500 degrees Celsius. Let me also copy the whole thing and then enter it. Okay, this is the elements which fulfill this requirement 200 to 500 degrees Celsius. Okay, Those are some of the features that we can use with the natural language. Start with the equal sign. Okay, we will skip and we touch more on this one by next week. So today we will focus on other work around in the Wolfram language. So Wolfram language is the programming language that we need to know the rules, how to write the language so that we can make the full use of it. And if you further go through with us, you will know that all the functions in the Wolfram language are started with a capital letter. Okay, like plot, solve the thing, the expand the thing, or this plot thing is always start with the capital letter so that we can easily understand what the function is doing for us. And all the functions are mostly follow with the square bracket. After the function name, you use a square bracket to include any argument inside or any expression inside. This is the second rule using the square bracket. And for the curly bracket, the purpose in the or the meaning of curly bracket in the Wolfram language is to include a list of elements. Okay, so maybe you have 10 elements, you use a curly bracket to group them. Or you have a range. Let's say you have a range. Say this A is started from minimum 1 to maximum 20. So this is how we use the curly bracket as well to include the range. Okay. And then lastly, use a shift enter to run the calculation, which we already tried just now. Okay, let us try again this one. To compute the example, n is the function's name, means that I want to get the numerical output, so n. And then I follow with the square bracket. So square bracket is after the function square bracket to include whatever argument or computation inside. Then I shift enter, rules number 4 to get an output. So this is how we get this. And I can try another one, expand. You see, expand start with capital E and follow with the square bracket. And then I key in my argument inside or expression inside, I get my output. Similarly, for solving the equation, I want to solve the equation, capital S, followed by a square bracket. And then the formulas 2x minus 7 equal to 0. Take note that formulas in Mathematica, we use equal for the equal sign. Okay, because in Mathematica, single equal is using for assigning a functions, which have different purposes, like a lot of other programming as well. You single equal, it means assign this value, this available with this value. But for equations, you just have to remember, we always use double equal sign. Okay, you can use solve this one and then press shift enter. You get the x. The answer is 7/2. And solve. And the solve, the difference is I want the answer in numerical output. So this and solve. Okay, answer 3.5. And simplify, of course, if you run it, shift enter, get your output as well. Okay. Curly bracket is using for multiple argument or elements or range and separate by comma, which I mentioned before. Like I want to do the integrate for a functions, and then I use the curly bracket, say the x is from the minimum to maximum. This is for the range, so that I know that I want to integrate this function. So I'll try, let us do it together. Integrate the x squared. And then the x have a range -5 to 5. So how should we write this one? So we just do integrate capital I, okay? And then followed by square bracket. If I click open square bracket, and then I put in my expression, x squared. You can use this one, x with the shift 6, the arrow pointing to the top, and then put 2. Okay, that's okay. And also, if you want it to be like superscript to the top, you can use the Control 6. Rather than a Shift 6, you use Control 6 in your keyboard. So you have a superscript at the top. And then press 2. Both way is fine. Wolfram language can recognize and know how to do it. Okay. So I want to integrate x squared, and then I want to give the range for this x. So I say x, I want to refer to x. X, I got the range from -5, comma, to 5. And then shift enter, you get your answer. Integrate. Okay. The format is exactly the same as the top. So you see curly bracket is for the range. Let us do a game for another function, say solve. Okay, capital X, solve, open square bracket, and expression. Expression, let's say I want to solve these two equations. As I mentioned also, curly bracket is to include a list of elements. Let's say I got two elements, means two equations. So I got first equation 2x minus 7 equal 0. So I type 2 times equal sign. You remember for equation in Mathematica is equal. So the second equation is 3x minus 2y equal 0. Okay, I want to solve these two equations. So I use a curly bracket for multiple element, and then I want to solve it in terms of x and y. So also I want to solve two variables. So x, using a curly bracket, put x, comma, y, and then shift enter. This is how we write our functions. Okay, I give you a few seconds so that you can write down this thing. So you can see curly bracket for multiple elements. Curly bracket here is for the range. Right. So next, we will talk a lot more on the list, because I think a list is quite useful and important when you want to deal with a lot of data or elements. Okay. For instance, if I want to have a list of elements like 1, 2, 3, 4 or ABC, we want to put it together, we use the curly bracket. So I just use it on. If I shift enter on this one, of course, it become a group of elements as what I input here. So the element, it could be numerical, it could be symbolic, it could be a picture, it could be a file, it could be a video, audio, it could be anything for the elements. Mathematica is able to handle all this. So it's not limited to just the numbers on it. It can be string or anything. So if I have a number, I can easily say I want to list plot the whole number here. Okay. So this is how I write this one, this plot it. So this plot, you get your output here. You plot all the points. You can select the size for your output by dragging around. Okay, this is this plot. And another function called range. Okay, range is automatically to create a list of number. Okay, when I say range 20, it means it create a list of number from 0 to 20. Okay, you can see range, sorry, from 1 to 20. Okay, range 20 automatically get a list. But I also can include more options inside the range function. I can say I want to have the range from, instead of default 1, I want to be from 3 until 20, minimum, maximum, and then this is the step size 5. So if I put this one, I enter, I get it from 3, 8, 13, 18. Okay, 4 elements created by using the range. Okay. And also I can have some other function. Some example is like reverse it. I can easily call this reverse function. So you can see the function name can be used inside the other functions. You can put layer and layer inside your function so that it can create something huge or some more advanced or complicated algorithms throughout these features. You can have a function inside function as much as you want. Okay, let's try something. Say, try to plot the value, to call out the value from 24 to 4. It means a decrease. So start from 24 to minimum 4 with an increment of -4. So how should we do this one? we can use a range straight away. Say I have started with 24 to 4 with a step size of -4. Okay, this is what we do. Or you can say you start from 4 to 24 with a range of step size of 4, and then put the reverse at the top, at the front here. Also can. Okay, both are same. And we can use a join to combine the element from multiple lists. Let's say you call data, it came in with different lists, but you want to put them all together using join. Today, we're just touching some basic functions so that you can get some idea what is possible. But for more in-depth, later on, we suggest you to go to the help file to choose and to look for the area that you are interested in, right? And for the list, we can do a lot of visualizations as well. Okay, for instance, you already know that I can easily have this plot like we tried just now. Okay, if I run this one, we get the plot with a point. And if you want to have a line to connect all the points, we have a function called list line plot. Okay, then everything is the same. So list line plot, we enter it, it connect all the points with one line. We call it list line plot. And without changing all the structure at the back here, you just change the function name. I want it to be bar chart. Okay, you just bar chart, enter it, simply straight away give me the bar chart. So Mathematica actually is quite straightforward because all the functioning is you can easily understand what you're looking for. So this is bar chart, and of course, if I change to pie chart, you get your pie chart. So 1, 1, 2, 3, or 5, 7, you can easily get all those things right away. Okay. And I introduce another function to you called row. Row is to arrange a multiple expression within one single row. Okay, so that you can see in one row. Let's say I want to have these 3 elements. The first element is called AAA. Second element is called B. Third element is CCCC. If I want to put all this together inside one row, I use the row, and using the, of course, because they got multiple elements inside, I use a curly bracket outside, and then I run it. They put together for all the 8 elements, the 3 elements with AAA, B, CCCC. And I can have the options in between this element, what you want to include. I can say I want to have a double dash line here. So this is within one row, I can have these 3 elements connected or with the dash line in between. Okay, this row. With the row, you can actually know that by these 3 elements, you can simply replace by these 3 graphs inside the row so that you can have all the graphs inside one row showing together. So let us try together to put all the list plot, bar chart, pie chart in what we did just now inside a single row. Okay, instead of using this dash dash in between the elements, we want to put a spaces, empty space in between with a spacing of 50. Let us write together. Row, open square bracket. Of course, I want to include these 3 elements, this plot, bar chart, and pie chart. So I use a curly bracket. So let us copy the first element inside here. I simply put the first element. Let's say I want to have this one. I copy the whole thing, highlight it, right click, copy. Paste it. Okay, this is the first element, and then comma. And let me go to copy the second element, bar chart. Copy it. Paste it. Comma. Third one. Copy. Paste it. Okay, now I got 3 elements. Okay, after these three elements, you see is grouped by the curly bracket. This one, it corresponds to this one. And then I want to have a spaces between. Okay, you can see this is after the curly bracket of the elements, I put a comma. This comma is this one. And then I want to include a spaces. Okay, spaces is the function that come with the row set that you can put how many space in between these three elements. So if you put enter, this is how I get. Okay, then I can have all those inside one row. Of course, there will be some other option of available for different output, like you can add your labels, regions, all those things it can be added. But today we are not going into that details, but just let you know that you can do some of this together. So you can simply change the spaces or the size, or you say, instead of doing this, can I have something easier to see rather than copy the whole function inside? Yes, actually, instead of copy the whole thing in, if you want, I can actually say, okay, this is the graph 1 equal to this one. So I give this whole output with a name, say G1. So if I shift enter again, now G1, this the whole thing have a name called G1. And this one, if I say G2 equal, running again, enter. Now the G2 is a bar chart. And then pie chart, I give a name, say G3 is equal to this pie chart. I shift enter. You remember you have to shift enter so that it know that it assign the value of pie chart to this variable G3. So after I assign the G1, G2, G3, instead of putting all the name inside here, I can use G1, G2, G3. So it looks nicer and much cleaner and easy to see. And if I shift enter and run the whole row again, you get the same output. Okay. This is how you can assign a values or variable names to any output that you want. All right, this is for the row. And there is something more advanced and for allow us to create much more bigger output is using the grid. Okay, instead of a row, grid allow us to create two-dimensional grids like, and this is the first row, this is the second row. So your output will be like two rows, A, B, C, X, Y, Z. But you can see that this is the first layer with a curly bracket, first row, second row, and outside of these two rows, there will be another curly bracket. This larger bracket means that you want to include the whole two rows. So you need to have extra layer of curly bracket to have including this thing. So if I have this thing, you can see the bar chart, pie chart, this plot chart, everything, or maybe I just change the name so that we can see easily. G1, G2, and G3. Okay. It doesn't matter whether I put this as a multiple row inside this cell. It doesn't matter. The one cell, it can be one row or it can be up to 10 row or 100 row. It doesn't matter. It's still considered one cell. So if I put it this way, or if I use it, enter and put it this way, when I execute it, it always came back with the same result. They are the same thing. Okay. So I got 3 graph, and I want to have a frame. This is the option for the grid to include a frame, and I want to include an item size. Means these 3 items you want to have a size scale of 0.33. The item size scale 0.33 here means that I want to have these 3 elements equally distribute throughout my screen. My screen here, each one is, the whole screen is 1. So this size is 0.33, 0.33, 0.33 for each element. This, so you can automatically distribute the size using this grid, and it gives me a frame. So this is option that you're using the grid. Right? Okay, next, operation on list. I'm not going into that inside this operation of this, but I list down all the options. You probably can run each of them after today's sections, because with the limited time, I just leave it here. So we skip the operation on list. And we come to the slide 13, the graphic example. Mathematica can plot very nice visual automatically. We'll show you some of the example by using, let's say I want to show the sine x. The x with a range -2 pi to 2 pi. Okay, so I want to plot this sine x. Some common mistake for a new beginner is we always forget the capital letter. So in Mathematica, no matter it's a sine, cosine, whatever, when they are a function name, you always start with capital letter. So sine is capital letter, and it always after the function name using the square bracket, not the normal close bracket. Okay, it will be square bracket for the sine x. See, I want to plot this sine x, then I get my output right away. For this plot option, there will be a lot of different options available inside this plot. So if I did put this one filling equal to with the axis, it's just a normal single plot. So just now, I get the option available under inside this plot is filling. I want to fill toward the axis. Or I can change other thing. I want to fill it towards the bottom. Is available as well. So there will be a lot of options available. That one I will leave it to you later on to go to a documentation to find out what kind of option you can add for your visual output. Okay, this is something simple, plot sine x, and then also you can have a plot 3D sine xy. So you can easily plot the sine xy. The x is -3 to 3, y -3 to 3. But something have to be careful is when we have a different variable like x, y, you can't put both x and y together. Make sure there will be a space between x and y, because if x, y are together, they thought this is a variable named xy. Okay, but we want it to be x multiplied by y. So you can either put x times y, or you can leave a space in between x and y. They are the same. A space between two variables means multiply. It's simply like that, okay? So if I plot this one, by giving a name called graph1, I can get my 3D. And if you put your mouse over there with the left mouse button, click on it, you can actually rotate, okay, using the left mouse button. And if you, while you rotate, if you click on your button shift, and you click the shift button, you left mouse button, you can actually pan the whole thing. Okay, you can see the symbol change that allow us to pan by using the shift. If you select the control button with the left mouse button, move up and down, you'll be zoom in and zoom out. Okay, so one is shift, one is control with the left mouse button. Okay, without any click, just a left mouse button, it's just a rotate. All right, so you can easily create some 2D and 3D visual in Mathematica. Then you can also copy the whole thing or import the whole thing to make use in other software as well if you need to. So you can easily save your graphic as, or copy your graphic and paste in other, or save, you can save in many other format as well. So if I save graphics, you can save in the PDF format, HTML format, BMP, EPS, GIF, JPEG, PNG, all the formats are available. Okay, you can simply save it and make use of it later on. But we also can use the import function in Mathematica or export function to easily import and export your graphics. So if I use an export function, I can give the name, say I want it to be export with a name, the name called text image.png. Okay, I want to export this file. The what file, the file name, or what image or what thing want to export. The thing I want to export called graph, graph1, because I already assigned graph1 is equal to this one. So I want to export the graph1 and save as a file name called test image with the format PNG. And I also can define the image resolutions. Okay, I can put everything as an export. If I run this one, it automatically create a file, text image.png. Okay, you create this file, and if you want, there will be a shortcut here. You see, I want to open this file. You can, or want to open my file direction. So you might wonder, I didn't tell the Mathematica to export, where to export. How do we know, or how do I know where he export the whole thing? Actually, by default, you will export to our working directory, which I am going to show you later on. There will be a default working directory. So whatever file import or export, first thing, you always go to the default working directory. Okay, if I didn't mention any specific directory, you just go to that. So we export to that one. And if I say I want to import the whole file, now it's much more easier. I just say import the file name. He already know where to look for because it's go to the default directory. So when I import it, straight away, come back the whole file. Now I cannot rotate, I cannot pan in and out because now it's only a PNG static graphic drawing. You cannot rotate anymore. It's a PNG file. I import it later on. So this is a simple import and export. If you want to find out more about import and export, you can go to the documentation also later on, right? Suggestions bar and palettes. This is something very handy, especially for new user, because you always show some function suggest us to do based on the output we have. So by just now, when I got this output, text image.png, this is the suggestions bar automatically out. See, it suggests us whether I want to import back this file, I want to open the file in the third-party software, I want to find it, open the file directory, or I want it to show the full file name. Those are suggestions options based on this output. So this is called suggestions bar. Okay, suggestions bar for us to simply click on the one of the button and get the next step automatically. So for instance, I got this functions x squared minus 10. Okay, if I run this one, I get my output like that. Okay, minus 10 plus x squared. It's still the same thing, it's just arrange it in this way. And then the next step, we say whether I want to plot it. Do I need to do the derivative for the x? Do I want to do the integrations? Or some other more option available as well? If I click on more, say there will be inverse functions, or maybe some function interpolations, or to find the loops, or to how to discriminate, or to all other things. Let's say I just want to do the integrations to this output. I just click X integral. So it do the integration for me. And next, maybe I want to do the, okay, simplify. Okay, simplify this output for me. You get this output. And lastly, maybe this one, okay, show me the graph. So I just plot it. Okay. So without knowing all those intermediate functions name, I just click on the suggestion bar. From here, I'll get until my visual output right away. Okay. If this is what we want, if you are satisfied with this output, what you want to do is you click on this symbol called roll up input. Okay, it will combine all the intermediate steps that we clicked just now inside one single cell. So you make your notebook more neat and you can see all the steps in one cell. So I just click on this roll up input. Then you can see from this output, what he did is he do the integrations, and then he do the simplify, and then he evaluate and give a plot. The plot with the range automatically is set for the best visual is from negative 13.4 to 13.4. Of course, we can change this one. Just say I want it to be 15, negative 15 to positive 15. I just change that one and then run it again. So they run from 15 to 15, or maybe I want to change to 10. Okay. Right. So this will be quite handy using the suggestions bar by using the button and the roll up together. Okay. Another help or wizard we call palettes, which is quite handy as well for us to create a lot of feature, is using the classroom assistant palette. The classroom assistant palette we can call out from the menu at the top here. Okay, click on palettes and then select classroom assistant. If I click on this one, you call out this whole button control palette for us to easily key in the feature that you want. It could be quite handy. Sometimes we will leave this palette on beside this notebook so that we can easily key in some formulas, doing some function with this palette. Okay, so how to key in the whole thing like this? Integrations, x squared. By using this palette will be quite easy. Let us do it together in this pink color input cell. So click on this one. I want to key in this one. So just look at the palette here. Integrations. So is there any function available? Maybe I go to, instead of basic calculator, I go to advanced. Okay, for the advanced here, you can see, okay, this is the template I'm looking for. So if I click on this one, you see that will be easily for us to fill in accordingly with this format. So lower is the first input. So lower is 1. You can type, but click the button here, 1, or you can use a keyboard button, it's the same. 1, and then the next one is the upper, you can tap it. You jump to the next one, or you use the keyboard tap. So upper is 10. So I can key in 10, and then I tap it. So this is an x squared. So if I key in x squared, so x squared here is the 1. So x squared with the superscript, I select this one. So let's say x, and then tap it, 2, x squared, and then I tap it again, and in terms of x, select x. So we can easily key in this symbol by using the palette, using this classroom assistant palette. And this traditional mathematics format, they are recognized, and if you shift enter right now, they'll do the calculation for us. Okay. And again, we try the other one, or inverse. So for advanced one, we can just, okay, inverse. You can go to the function to find some of the function available, say basic command here. So a lot of other command available. You can just click on it. See, let's say if I can find the inverse. Okay, this is for the matrices and linear algebra. I go to this command here, there's an inverse. I click on inverse. Okay, then I click on the matrix, and I just fill in accordingly. 1, 2, 3, 4. So you can use this one, or you can use your keyboard and tap and tap and tap. So done. And shift enter, get the output. So with this palette, that'll be quite handy to call out all the wizards. You see the basic command is all available. 2D, even for the plot, how to get the plot with the color, with the tick, with the axis, frame, grip style. You can select all those things in this palette. For 3D as well, whether my 3D plot, you want to include the range, the style, the mesh, the axis, constant, all those things can be selected in this palette as well. Right? So this is how we work on the classroom assistant. Next, help. This is important for us to know where to get help if we have a questions. Using help, you can use a question mark. Okay, you put a question mark in front of any functions and then run it. You show us the summary. Okay, it show us a summary that you're looking for to get a quick explanations on the plot, like the plot with a expression here give a range with this format, and then you give a plot. So the explain very well. If I got multiple formula or expression, you use a curly bracket like that. Okay, this is using a question mark. But let's say I know there will be some other plot like parametric plot, control plot. There are so many other plot. I can use this star key to find out any words that contain plot before at the front and at the back. So you put question mark like that, you call out all the functions that contain this word plot. Okay. You see the Mathematica, we got 6,000 or 7,000. I can't recall how many 5,000 of function available in Mathematica. Those are some of them. So if you, let's say I'm looking for plot, I click on this one, it show me the summary for this plot as well. So you can put a question mark with those extract to call out this, just like joker key, so that you can call anything in front of it. And also you can use a Control-Shift-K while you have the cursor at the functions. So if I have the function name like this and my cursor here, I use Shift Control-K. You call out the wizard for us to easily fill in. So if I have this one, I select, oh, okay, maybe this is what I want. I just click on this one. It automatically came out with this wizard so that I can easily plot it. Okay. So X, I fill in, so this is from -3 to 5. Shift Enter. So this is a shortcut for us to call out the template for us to fill in. You don't need to remember or memorize all those steps or all those format that you want to fill in. Just use a Shift Control-Shift-K, right? All right, next. Creating compound expressions. So this is where you want to build up your algorithms. You always need to create with some assigning a value for a variable that you need to use later on. So like I mentioned earlier, we use single equal sign to assign a value. So I give a value for A is equal to 12. I give a value for B is equal to 18. And then I can do it later on, say, how about 2A plus 3B? That is how it actually came out the answer. So you can assign a value and then use it in the following calculations. Okay. And of course, if we don't want to use it anymore, it's always a good habit to clear the assigned value so that you won't match up later on and you somehow you forgot A, you already give a value and then you use the formula A in other formula again, then you max out the whole thing. So if you use a clear, capital C, to remove any assigning value that you assigned before. So you see the variable now become blue color. When it's blue color, it means they have not recognized in the library yet, means they are not assigning any value yet. So it's in blue color. When it's in black color, there will be something already assigned. Okay. Okay, this exercise here is to combine all the above steps with semicolon, this one in a single cell and return last result only. Okay, this one we did with the 3 separate cells. But with the semicolon, you can put everything inside the same cell. So what we do is, let's say I copy this one, copy. So within the same cell, I paste it. I use a semicolon. That means that please do this calculation, but don't show me the result and move on to the next. So that is the first one. The second one, I copy again. Second one, and then semicolon. And then third one, just run this one. Third one, run this one. So that you see, this is, don't show me the A, semicolon, don't show me the B. And last one, I didn't put anything, means that it showed me the last result. So if I shift enter, it gave me the output. Right? So this semicolon, you combine all those function within one cell. That will be handy because you only need to shift enter one time to get everything you want, rather than you go to specific one cell by cell to execute it, right? So you use the my column. Another thing is table. Table is very handy, means that you run it repeatedly iteratively, so that from I is from 1 to 10, you run it 10 times and show all the result. This is how what it means by table. Table it means put all the result on the table to show me. So I want to see all these things. And once you run this all table, you can use a total. Total it means sum up everything. And if you still remember the percentage, refer to the last output. So sum out the last output, sum those out. So we put the total, you get the 385. Okay. So that now you already know you can have all the previously we already tried out, say we put a function inside another function. So this page is showing us that you can put all those things inside a function. So I can put this one, let's say I copy the whole thing table, and at the front here I can put the total. Straight away include the whole thing. So a function inside a functions, then you don't need to show out the intermediate output. Instead of using the semicolon and with two row to show those out, you can put it inside it, so that you don't even need to use a semicolon. Okay. Of course, after that, you see the A and B is in black color. It means A got a value, B got a value. How do I know whether A got a value? Remember, it's apply the same thing. I can put a question mark A, and then I shift enter. It show me that A, it got a value of 12. Okay. Then put a question mark B. I run it, it said B got a value of 18. So this actually show me A and B already assigned with some value. So how about if I clear it? Now A and B come back to the blue color. So if I run the B again, what it show? It show global B. B is just the B. It don't have anything. Okay, this is how it looks like. So it's good practice to clear the things after the assignment. Okay. So far, everyone's still okay? Still with me or already? I think Peter is answering a lot of questions in the chat room. So I hope everyone is doing fine. And next, we want to do some Unix conversions, especially if you are involved, maybe you're from physics or anything that involve a lot of Unix conversion inside your algorithms or inside your calculation. They will be quite handy as well, especially if you got the built-in feature using the natural language. So it automatically do all the things for us. For instance, just now earlier we mentioned to call the free-form input, the natural language, you use the equal sign. Equal sign, become the whole cell is a query. The whole cell is a natural language. But right now, for these sections, I want to show you that I don't want the whole cell become a knowledge-based engine. I only want the server to interpret the certain words. So I use the inline free-form input. Okay, you can insert the inline free-form input by using the insert here, or using the shortcut key control plus equal. Okay, so this is how I call up. For instance, I use a new input line. I say control equal, it will become something like this, orange color. And then I say, okay, give me the, I want this one to be 20 meter. Okay, or maybe I just put M, see whether he know, or put ML, see whether he knows. So I put 20 ml, enter. Okay, do we understand this ML? So if I move my mouse over there, it's okay, this unit is recognized as milliliters. If this is what we want, we can just accept this interpretation. Click on it, so we know this is 20 ml. So within the whole calculations, whether you input in difference unit, they'll do it and convert it automatically. So the same thing, if 12 minutes, then if this is what I want, I accept this one, this 12 minutes, and this is 12 feet, and this is 3 meters. Even if I didn't click to accept, if I just leave it, they'll do the calculation for me as well. So if I shift enter, it automatically convert it and do the calculations. Now the output is in feet. Of course, we can convert the unit later on. Okay, or you can use the suggestions bar at the bottom, say convert to inch, meter, mouse, or some other thing if you want. Okay, you can easily convert to any other. So in Mathematica, you use this one, control plus equal, to call in the inline freeform input. So let us try the calculation for this one. 10 meter per second times 5s. Of course, if you don't use the this inline freeform input, you still can do the calculation. Let us try one to show you. So let me try m over s. I just simply type m over s without calling the inline interpolations, and then multiply by 5s. Okay, if I shift enter, Mathematica still will automatically do the calculation, but the m here is just a variable or just a symbol. You don't know what it means. Okay, it's different from what I show at the above here. So the correct way or the proper way would be using the inline input, or you assign a proper unit. So when you do the import, export, or conversions, or connect to other software or other machine, they'll be interpret correctly. So what I need to do is I say control equal 10 m over s, and then enter. Say interpret meter per second, correct? And then I say, how about multiply by control equal 5s, enter. So this is second. So everything is correct. If I run it, now the answer is 50 m. So if move my mouse over there, you'll see the unit it recognize is meters. So this is very important if you need the values to be extract for any other machine learning or calculation later on. With a unit is much more meaningful compared to whatever the just m is. For instance, we can also use the this auto interpolation for currency as well. So I can do this as well. Say control equal what is the amount of our M32 ringgit negative USD $5. So I can just say 32 or RM32. Yeah, Malaysia ringgit, correct. Minus control equal USD 5. Correct. So I run it. We do the calculation. So they use the current latest conversion rate to do the calculation. So it will be around 10 ringgit after the minus up. Right? You can always use the suggestion bar at the bottom here to convert the unit as well. Of course, all those using the inline input, they will need the internet connection because it sends just real time to do the conversions. What if you have no internet connection? How to do these unit computations? By using the Wolfram language, this is how actually you write the functions using a quantity and then give the unit at the back here. Okay, with capital letter, then you know this is what it is. So this is how it is, unit feet. So you can also say, I want to do the calculation 2 feet plus 3 meter. This is how I write quantity 2 with a unit, quantity 3 with a unit. I do the calculations and this get the answer as well. Okay. And then unit conversion, the quantity and the feet. And then I want to have a function at the front here, say unit convert to meter. Then you convert to meter. So this is meter, right? Of course, if you want the numerical value, there will be a numerical value, 3.6 meter. Okay. All right. Beside all those conversion, I think data import and export is also relatively important nowadays. You need to import your data from out there inside Mathematica for computations. So this is how we do. We use an import. You can import the data from any sources, whether from a website directly or from an Excel file, from CSV, for any other format they are available. Just have to follow that to tell Mathematica say the format, the data you import, whether it's a graphics, data, or audio, all those things, you just have to mention, okay? So let's say I import this default data, okay? This is a score. And I want to import this data and assign it with a value called data1. So I import all those things. There will be 5 rows of data with each people with their first name, last name, and their score. There will be 5 people, and all those saved as a data1. Okay, this is how it looks like. And then I can use some of the feature or some of the functions name to call out or to manipulate all those data. For instance, something I want to introduce you is called part. Part is to call out one part of this element or one part of this data. Okay, so you use part, the square bracket, or your shorthand is like this. Shorthand, it means using the symbol rather than writing out the whole functions name. Using the symbol, they will have the same functions. So this is your shortcut. So first one, I say I want to part out or call out part of this data. The one means I got 5 elements or 5 rows. I want to get the first row. Okay, so when I click data1, this is the whole series or whole list, and the first element is this one. So we get this one. And as I mentioned, we can use the shorthand. Shorthand means I still get the same data, but I don't need to write the part. People would prefer to use this way because it's much more easier and faster to write. So I just use the name for this element. See the element, the name for this, the whole list. The list is called data1. So data1, then I follow with this double bracket open, and then I want to have the first element, and then double bracket close. Then shift enter, I get the same thing. So they are exactly the same. So you can see this is much longer and this is way shorter and faster to write. So data1, double bracket, put in the element you're looking for, double the bracket close. And also we can specify which row or which column, because if you can see here, that's 5 rows, 3 columns. Column 1 is a first name, column 2 is last name, column 3 is a score. So if you look at that one, we can specify with the comment. This means that I want to call out one of the element, or the element will be the condition with the X. This is the row, with a Y is a column. Okay, the row I want to call out, the row is from row number 3 to, this means that 2. From row number 3 to the last row, -1 is the last row. So I want to call row number 3, which is Bob, is row number 3. Last row is Michelle. Okay, I want to call the row number 3, so will be Bob, Bell, and Michelle. And I want them to be the first column. First column is their first name. So there will be Bob, Bell, and Michelle. So this is how we write and how do we manipulate with our data. Okay, so we can also use this one. Say I want to have the third person until the last person, this is row, and then I want it to be the first, and maybe instead of the first column, I want to be a last column. So I get all the score for all of them. Okay, let us try some example how we want to sum up and get the average score for all these 5% within one functions or one single cell. So make use of this data. First, you want to see how to call out only the score. And then I want to find the average or the mean value. Okay. So this should be the same thing. Let us do it together. This is data one. Open square bracket and close it. So it becomes the shorthand like this. And I want it to be the every person. So all the row I can have 1, then until -1, or you can 1 until 5 is the same thing. If you know it's already 5, but normally we don't specify 5 because if I put -1, it could be 10, it could be 20. It always sum everything until the last one. So this is a row number 1 until the last row, and then I want it to be the third column for the score. If I put it this way, I get all the score. Okay. And if another one is, instead of writing the first row until the last row, since we are looking for everything, looking for all data, Mathematica have a function called all. We can also key in all, means all the row. All row and the third column, you get the same thing. Okay, so they'll be easier. And then I want to get the average. So what I need to do is I want to get a mean for this data. So I put a function called mean. Of course, you might say, I'm not quite sure how do I know there's a function called mean. After you look in the documentation for all those calculations, your function will be categorized in different subset. So you can find all these functions. If not, you can also open the palettes to find out some relevant functions that are available. Or one thing is, I believe just now the suggestions bar should be able to come out, right? Yes, there will be a suggestions bar. To sort out, to total, to min, to max, or even you can click on more. There will be much more option available as well. So if I click on min, you just get this one. So you know that min is available. So instead of writing this, I can also put the min at the front of this input and close it. So straight away I get the min. And if I want to have a numerical output, I put an n at the top, at the front, very front. I put an n here. So give me the numerical output. Okay, so n mean data. All right, this is some simple manipulate with your data using part. Of course, there were much more functions available, but we just touch on this one today. And next, we want to show you when you're using the import and export, you can always define your working directory. Okay, if I just type directory and open close bracket and the bracket inside here, I run it. You show me that my current working directory is this one. Yours one will be different. Of course, that will be your default working directory. Okay, by default, it should be on documents. Okay, on your PC documents, but it could be different. This is my working directory, and then I can also check notebook directory. Notebook directory means that your current notebook, like this one, the notebook name shown at the top left here, Intro to Mathematica 2022.mb. It means where this notebook currently are. So if I run it, they say, okay, my current notebook directory is on my desktop. Your one, if you download, it could be on your download file or maybe other folder that you already move on. So directory and notebook directory are different. By default, working directory is this one. When I put show import export, the first thing you look at is this directory. Okay. But I also can set the working directory. I can change this working directory to the same directory as my current notebook are. So this function, it means that make this working directory similar to my current notebook folder. The reason is that if I got import export, the file is always have saved in the same folder as my current notebook. So easy for me to look for. But of course, there will be your own preference as well. This is what I do sometimes. I set the directory, the working directory, as my notebook directory. So whenever I do the export picture data, it always throw into this same folder. Or maybe I got external data, I just put in this folder. When I want to import it, I straight away import with the name you call from this working directory. Okay, this is what we normally do. But there will also some alternative. If you want to manually select your folder, we use something called system dialog input. So there will be longer wording and sometimes might not be in. I always cannot remember this name as well. System dialog input. Okay, you can set your directory to any folder you want to choose. You just put in, say, my system dialog input. If I run this one, you actually pop out a wizard. Then this is what the window title I said, choose your default folder. So it show at the window dialog here, choose your default folder. So you can always use this one to select your default folder. I can put it, maybe I added my desktop. I click on this one. So it becomes, this is my working directory. Okay? Or maybe any default directory that you want. You're using this function to choose it. Select your default directory, maybe to the document. You choose it, and then move to document. Right? So when you export the time, it always throw to this directory. So export, maybe I want to export. If you still remember just now, I got the data 1 in the previous example. Data 1 is all the data 1 is all these 5% names we score. So this is data 1. So if I export this data 1, I give it a name. Say export this data and give it a name called data1.slxx. So I can open in Excel. I don't need to specify which folder anymore because I already set my working directory. My working directory is this one, document, under document. So if I open my file directory, I click on this one. So let's click, let me see. Instead of showing the file directory, I can show the full part file name. Okay, so this is inside, it show the full part. So it show this thing inside my working directory. So know where to find it easily. And I can open this and can export. This is export a data. I can also export a graphic directly that I shown you previously. This is export the block X inside a file name called image PNG. If I export it, okay, this is the file name. If I import it back again, this is how it looks like. What else? Export data number 2. Okay, if I have another data that's a manually key in, I got 3 rows. Row 1 is 1A, row 2 is 2B, row 3 is 3C. 3 row and 2 column. I want to export this one, become a file called data2. So if I run this one, I got data2 ERX. So if I click open, you open in the Excel. And this is how it looks like. This is exactly where it looks like, and the file name is data2. Okay, this is how we do the export right away. And we can import it back. After I export, I can use the import it back. When I import it back, what I need to do is I want the data only, just in case this file inside, they probably got other things. Maybe you get audio file, video file, or maybe some other visual. I say the one I just want the data. And then there will be 3 elements at the back here, after this data comma, it stands for sheet. You can say sheet number 1. And then row, I want to import all the row. And column, I want to import the second column. So if I do this one, Shift Enter, you get me the second column is A, B, C, all the row, and sheet number 1. So this is how I call out the data. Okay. And system dialog input, it can be included in your import and export for Excel. I think I list this for you. Users that when you want to export the time, you use a system dialog input, you can choose which one to export or where to export. Manually choose rather than using the using the default directory. Okay. By using system dialog input, you'll be much more flexible. Straight away using this one, choose the file path and use and select your own file name, and then you export directly. Right? Okay, we have last few slides. This slide is about defining our own functions that we want to use it later on. Okay, defining functions are using the this symbol column equal sign, or we call delay assignment. Okay, we want to create a functions called function x. This function x is x squared plus 5x. You see the pattern f function with a square bracket and then x underscore here. The x underscore, it means anything. Okay, you can create your conditions. The x, it can be only real number. The x, it can be only numerical, or you can x, it must be the even number. You can put some condition. But if I don't put anything, x underscore, it means anything. So my function, the x could be anything, and then the function, the whole formula will be x squared plus 5x using the delay assignment. So if I run this one, you can see the f, after I define it, it become black color. So f is become black color, and now you already know that f got a functions defined. So if I put a question mark f and run it, you show me, okay, this f, you already have a function. It means x squared plus 5x. Okay. And if right now, just now I put the x, fx underscore, the x is become 4, what would the whole function become? So if the x is become 4, the answer is 36. If the x is become pi, the answer is 5 pi plus pi squared. If the x is including a list of elements, 1.23, 3 pi, and 5, you get the list of output. If the x is number a squared plus 1, you also replace the x straight away with a squared plus 1. Okay. And with this, we can also using it to execute and do some if then else condition. So you can say you define your whole fx. Okay, your fx is when the x is larger than pi, do this. Print is not like print out a physical paper. Print is just print on the screen. Print on the screen say x is larger than pi. Else, or is not larger than pi, then you print this word x is not larger than pi. So that is my function. If I define this function, okay, previously I already defined, I should clear these functions for before I follow up. Of course, it could be okay without clearing, but it's good practice to clear the previous defining function. So I clear this one, then I define a new function again, or I just simply give a new function name, say my function. You can always change this one. Let's say my functions is to have an if then else check. So if my functions with a value at E. Then you check already, say, okay, E is lesser than the pi. So you go to this option, print that E is not larger than pi. Okay. So you can always define your own function that you can call out and use later on. Right. So that I just clear my end. Right. Okay, we have 10 more minutes, so I probably have to sum up the last slide with the interactive models. Okay. Like I show you in the very beginning, people like a lot of Mathematica feature on this dynamic interactive. You can easily create with this function called manipulate. Okay, you can create this one and then easily demonstrate or share with any other people through the cloud. Like you have this notebook this morning through the browser. I just upload to my cloud, so anyone can also open this file, whether they have Mathematica license or not. They still can interact with the model you create in the file. The only thing limited is they cannot create new thing, but they can interact everything inside there. Okay, so this is something very handy and useful. For instance, if I want to bring the x curve, of course, we already used this example a lot previously. I can plot this one, but most important thing is I can also make this become an interactive graph by using this function called manipulate. Okay, so the end user can interact with it. So how to create this one is I just need to add a name called manipulate at the front. Let us show you something first. Okay, let's say I got this one. Instead of sine x, maybe I want to sine 2x. Okay, maybe I want to sine 10x. So we can always change this one. So what if I want to make this become a variable that can be slide or can be toggle along the calculations? So if I choose this one, let me copy the whole thing and put it in a new line. I change it become A. Okay, the A, it has to be a range. So you have to tell them the age is from maybe from -2 to 20. Okay, and then the whole thing is should be included inside the function called manipulate. Manipulate, close the whole thing. If I run this one, of course you can get this manipulate easily. And if you click on this plus sign, you can see the actual value of the A. Okay? A, you can run it from forward, backward. Okay, this is how actually you can turn your static output immediately become a dynamic output. Let us try on this thing. Manipulate, plot, sine, and x is exactly same with what you do just what I just do. So we just write again. Manipulate. One of the help function in Mathematica is whenever we type a new functions, they always came out with the suggestions of most relevant functions follow with what we want to type. So this is very handy as well. You don't really need to finish the whole thing. Manipulate, if this is what you want, you just select it and then close it, plot, sine. So just follow whatever at the top here. Then is x from 0 to pi. You might wonder how to key in this symbol pi. Of course, we can use the palette to find the symbol, or the shortcut key is always using the keyboard, the escape. If you type the escape button at the top left in your keyboard, escape, and then you type P-I, and then escape again, you change to the pi value, pi symbol. Okay. Similarly, for the alpha, beta, you use the escape A, escape will be alpha, escape B, escape will be beta, the symbol. Okay. Let me finish this one. So n -5, 5. Run it, I get my n. Okay. But one thing is, we will suggest you when you have the plot, you use a plot range. The plot range is important to fix it because, for example, this one, if you notice just now, you will actually, Mathematica will automatically show the best scale. You see, the scale right now, they don't have a positive, so you ignore the positive. You change the Y scale based on the best view on the screen. So it becomes sometimes quite annoying, especially when you're running this dynamic thing. So you keep on flicking around. So what we need to do is we want to fix the plot range so that it always stay with the range from -1.1 to +1.1. So if you run this one, or maybe I just copy the whole, to be lazy, I just copy the whole part of this one. Copy it. And then I just put inside here. Okay. And instead of having it flipping around, I just need to, after this plot, because the plot range is inside the option of plot. So if I put this, I separate this one, you can see. This is a plot functions. So plot function, I want it to include a plot range. So I put a plot range inside here. 1.1. If I shift enter again, now if I open this one and let it run, you'll see the scale will never move so that you can see the curve in a better way. It won't flicking around, right? So this is how we use the plot range inside the manipulate. Okay, next, you can include many sliders or many variable inside one simple this GUI or output. So instead of just an n, you can have many things. So I can have a functions, I can have a frequency, I can have phase, and everything is with the same format. So you see, manipulate, follow with this, the whole plot thing is until here. It's much longer compared to previous one, is because I add in much more options. For instance, I want to show the tips in the axis, so that the tips with a range from 0 to 2 pi, and with the step size of pi over 3, and show it automatically. So inside the x-axis, and I want to have a plot style, means the curve I want it to be thick. I want it to be a dashed line and in red color. This is extra thing you add. If you remove these options, you still get a curve. You just don't have this feature on it. It doesn't matter. Okay. If let's say we ignore this one, we come back to this function. Remember that just previously we used this fn as a sign, but now you can change it. Instead of sign, you probably want to have cosine, tangent, secant. So instead of sign, I change it to a name called fn. Fn, it can be used later on. Say fn is, okay, including sine, cosine, tangent, secant, cosecant, and cotangent. Okay, it put at the bottom. And instead of a, I use the fq. Fq is a frequency. So what I do here is I say this is a frequency. Maybe I just remove this one so that you won't be confused to read so many coding. So this is how it should look like. FQ from minimum 1 to maximum 5. Okay. pH, instead of changing it, let me copy it out. So when I change it, I still have this. I still won't mess around with my existing code, so you can see the difference. So this is how it should be look like. It should be FQ and this would be pH, and this would be function. If I run this one, you get this. So get a curve, dash, thick red line, and then you can choose your functions with the bottom here. Okay. But then this is FQ and pH. What I did just now, when compared to this one, is instead of FQ, I put another curly bracket. Then what is the 3? It means the initial value. So when I run this one, I want the curve to show at the frequency of 3 initial value. Although the range is from 1 to 5, I want the initial value to be 3. And I want the name to appear as the whole word frequency rather than FQ here. Okay, so that is what it means. So this one was the same. pH, I want it to appear as phase, this word, and the initial value is to be 1. And this one, I want the initial value to be in tangent function and the name to show as function. Okay, and the control type I want to have as a button bar, radio button. Okay? So there will be some other control type as well. And if I run this one, you can see the name is changed as frequency, and then you have an initial value of 3. Okay. Function initial is tangent. This is how we control our output. Okay. Last one, manipulate is not only working for the graphic, it can work in all expressions. Okay. Or we can also use it for calculations, like this one with the step size. I run this one. So when n is increased, you expand this whole things. The n is 1 to 100 in the increased step size of 1. Of course, you can change the step size to 5 if you want, so that every step size is 5. Right? All right. Today, 2 hours is very packed, and I just like flying through with you, blah, 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 blah. I hope you are okay with that. I know this is a bit hard for everyone to follow the speed because I just have too many to include inside this 2 hours thing. But something before I let you go is, if you notice all the functions name, I actually put it in bold and in the blue color. You can always click on it and it bring you to the documentations. The documentations is something that important for us to further explore what is possible. Okay, so if you click on the plot range, you show me the plot range with especially how to use it with the example. So it show a lot of example with the plot range here, and how the plot range can do this, and some plot range can do that. So there is a lot of example, and you can further click how is the applications, what will be the property relation and some option available. All those are very good explanation for us to understand, and especially all the example here, they are dynamic, means that I can go in and change the value and run again. You can straight away see the difference. So it's okay for us to try and error to further explore what is possible. And how to come in here that I mentioned, you can click on this one, or you can go to any functions that we just now key, and you put your cursor on that one. You pop out with this symbol. You just click on this I for the help. Okay, it will be same as calling out for the documentations on this function. This is how we get the helps. Or alternatively, you go to help and choose the first one, Wolfram documentations. Inside here, I will highly recommend everyone to come in here. I always came in here to look for anything that probably, I don't know, because there are 6,000 or 7,000 of this function available. There are too many of it. So inside here, you just go to the area probably that you are interested or you're looking for, whether it's symbolic calculation, numeric calculation, you want to do a graphics, you want to do image, you click on this one, they'll further detail in different category like graph visualization, how to get a visualization, how to get your plot with all the axis, label, everything is all available inside here. or you can simply type in the function name at the top search button. Or another one is scroll to the bottom. There will be some very helpful resources, the workflow, how to working in notebook. You can click on here. It show you how to find help, how to get style with all the step-by-step. Okay, if I could click back one, let's say I further down, how to working with data. You click on this one, it shows us how to import a file, how to scrape data from a website, how to analyze file in a directory, or how to customize a data sheet. All those are with a step-by-step and a visual available. So there are a lot of free resources to help you get started. So do not worry and do not afraid, because those things are available and is at your hand. Okay. All right, I think we'll call it a day for now. If you have any further questions, you are most welcome to come back to us. You either write email to us, or we'll see you on the next 3 sections on Thursday, 10 a.m. morning as well. So the webinar ID will be the same. Just join it on time. And for next week, we will focus on the knowledge base engine to show you how to make use of those knowledge base and the data analysis. Okay, I hope you find today's interesting. And if there are other people who would like to join, or friends would like to join for the next coming sections, they are most welcome. Just let them fill in the registration form so then we can send them the material as well. All right. Okay. Thank you. Bye. Thank you and bye-bye, and hope to see you again next week. Thank you. If you have any question, you are most welcome to post in the chat room as well. Right. Yes, sorry about the, I forgot to mention about the attendance and certifications. So there will be attendance certificates available for everyone. I will put the link on the chat room now so that you can key in your name to get the certificate. For those actually that are already left, if you know they have missed the certificate, please let them know about this link. Let me put in the link now. Sorry about that. Yeah, this is the link for getting the certificate for today. Yeah, after you key in your email and your name, you should be able to get the certificate right away. Please pass it to your friends that had left the section just now. Because the link will be available for a while only. We won't leave it on for the whole day. So. Any question? I see there's somebody raising your hand. Mr. Afan? Yeah, you may speak up. Anything we can help you?
Yes, bro. Am I audible now?
Oh, yes. Okay. I hear you now.
Yeah. First of all, I want to thank you. It was very knowledgeable session, and now actually I am in first semester, so I have to choose any language for my PhD. So I am confusing which language should I select. Means I have MATLAB in my mind. Let's suppose or Mathematica or Python in my mind. So what language would you suggest? And from this session, I really love to do my research with Mathematica. And the second question is, I am from UTM, so I cannot get free Mathematica software. There are other universities are coming in options, but UTM does not appear in option. So from where can I get?
Okay. Peter, you want to suggest for Mr. Afan about this thing? Yeah, for getting the license, because UTM currently they have not going to have the license option at this moment. I believe there are a few ways you probably can do on this one. Yeah, you as suggested, you probably can talk to Dr. Norma. She has been working on the licensing issue at UTM for Mathematica. Hopefully, it will be work out for you so that it will be available again in UTM. It was available in UTM for past few years. Okay, and another option is some of the researchers they actually bought a license at their own with their research grant. We understand that some of the researcher and some of the lecturer, they do own some individual license as well, rather than the group license.
Okay, okay. Thanks. I will connect with Dr. Norma.
Yeah, that would be good.
Thank you. Thank you.
Thank you. Anyone have any question, you may come back to us as well. Okay. If not, then we will call it a day, and I will see you again on next Thursday. All right, then. Bye-bye.